Welcome to the WION Podcast. Today we're doing a bit of a deep dive, way back in time. We're talking about the very early days of our solar system.
That's right. Specifically, looking at Jupiter, our resident giant.
But not the Jupiter we know now, right? Something bigger.
Exactly. We're talking about a period maybe 3.8 million years after the very first solids formed, where Jupiter might have been, get this, 2 to 2.5 times its current volume.
Whoa, and on Jupiter's already enormous. It's like 2.5 times the mass of all other planets combined.
Mm-hmm.
And it was double that size back then. That's almost hard to picture.
It really is. And that immense size, that early gravity, well, it didn't just sit there. It played a huge role in shaping everything else.
Right, like how the other planets formed, where they ended up, our own Earth included, I guess.
Precisely. Understanding that early massive Jupiter is kind of key to understanding the whole layout of the solar system, you know?
Okay, so how do we know this? It was billions of years ago.
Well, the clues are subtle, but they're there. Scientists looked at Jupiter's inner moons, specifically Amalthea and Thebe.
Tiny little things, relatively speaking. What could they tell us?
It's about their orbits. They're slightly tilted relative to Jupiter's equator.
Wow.
And that tilt, it seems to be a leftover signature, a memory, if you will, of when Jupiter was much bigger and its gravitational influence was, well, different and stronger in certain ways.
So the moons got nudged into these tilted orbits by baby Jupiter, and they just stayed that way.
Sort of, yeah. As Jupiter contracted to its current size, the gravitational forces changed, but that initial tilt remained locked in. It's like reading ancient history in their current paths.
That's pretty amazing detective work. And this finding, this huge early Jupiter, it supports a particular idea about how planets form, the bottom-up method.
It does align well with that, yes. The bottom-up idea is basically that planets start small, dust, rocks, pebbles, all sticking together.
Right, like Earth and Mars. They built up slowly.
Exactly. And gas giants like Jupiter, they started that way too. But once Jupiter got big enough, maybe around 10 times Earth's mass, something changed.
What happened?
Its gravity became strong enough to start sucking in huge amounts of the hydrogen and helium gas that was all around in the early solar system.
Ah, so it hit a critical point and just ballooned.
That's the idea. A rapid, intense growth phase.
But why didn't that happen closer in? Why didn't Earth become a gas giant?
Good question. It mostly comes down to location and temperature. Closer to the sun, it was hotter, and there just wasn't as much of that light gas available or stable for planets to grab onto. Jupiter was out where it was colder, with plenty of gas to fuel that rapid growth spurt.
Gotcha. So location, 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 even for planets.
Pretty much. And during that supersized phase, its magnetic field was also likely way stronger, maybe 50 times what it is today.
50 times. Wow. The early solar system sounds like a really chaotic, dynamic place.
Oh, definitely. Very different from the relatively calm state we see now. But it's incredible that we can piece together that ancient history from clues that still exist today.
It really is. Thinking about Jupiter as this even more colossal presence back then, it changes how you see the solar system.
It absolutely does. Shows how much things have evolved.
Incredible stuff. Well, that's our deep dive for today. It just goes to show the kind of secrets hidden in plain sight, even in the orbits of tiny moons. Definitely stay tuned for more such intriguing stories to come right here on the WION Podcast.